Welcome to another episode. In this video, we will show you how you can install a redundancy gateway in your network using the first hop redundancy protocol with the HSRP, which is the hot standby redundancy protocol, Cisco proprietary protocol. If you look at the topology, we have two routers and then the cloud here simulating the internet. That's R2, where we have the Google DNS sitting over there. So this web server is configured with an IP address in this LAN 10.20.20/24 network. So we can verify that to the command prompt by issuing the command ipconfig. Here you can see 10.20.20.5/24, and its gateway is configured with 10.20.20.3, which is the IP address of G0/1 of router 3 here on this network. So EIGRP is also used with basic configuration to ensure there is reachability throughout the network. So that means from this web server, we should be able to ping the Google DNS server. So we can test that by issuing the command ping 8.8.8.8, and you can see that reply is coming on very well. Okay, so the other thing is we can also trace route from this web server to this Google DNS, and you will see that the route that is taken is going to be through R3 because that is the configured gateway address. Trace route to Google DNS server, and here you can see the first hop is 10.20.20.3, which is R3 IP address G0/1, and the second hop is the Google DNS server, which is 8.8.8, sitting on this R2 acting as our internet cloud. So if we do a continuous ping from this server, this web server, which has to be all the time up, and so that people on the internet can be reaching it. So here we are simulating that you have this web server in your network, and people from the internet need to be accessing this web server, maybe some of your website and so on and so forth. So if we attempt to shut down this link G0/1 on R3, which is currently acting as the gateway of this web server, so that web server will no more be available. So we can do that quickly by going into the command prompt and go to global configuration mode of R3 and go to interface G0/1, which is the interface that is connecting to the LAN where the web server is located, and of course the gateway, and then we shut it down, which is shut down. So that interface is now down. If you go back to the web server, you will realize that the traffic that was coming from web server to the Google DNS is now breaking. So that means because the link that was acting as the gateway for the web server is physically down, that the web server also will be down because it is right now has no idea how to get to the outside world or to the internet because its gateway is not available. So we know that the gateway is responsible to carry traffic from any client if that client is trying to access other network or internet work. So as you can see, the traffic will continue to be timing out, and that means this web server is no more available for people to access from the internet. So the web server will never come back online unless and until that this physical link has to be fixed. So to fix that, we have to go back there and say no shutdown. So imagine this happens in a network and this downtime takes a whole day, for example, for this link to come. Maybe this could be as a reason that this router itself goes down completely, crashes, and it takes some hours or days before you can bring it back up. So that whole time, your website will not be able to be accessed by people from the internet. So let's see how we can actually fix this problem to make sure that if this gateway here or this router that was acting as the gateway for the server is no more available, so the web server can automatically switch over to the other available router, which is R4 here, and traffic will flow out to the internet so that this web server will not be down for that long time. To do that, we are going to use the HSRP, and we make sure that this router R3 will be our active router or our master router. And as long as this router is up and running, it will be serving as a gateway. And the second router here, R4, will be the standby router. Standby means it's going to act as a gateway if the active router is no more available. So as soon as the active or the master router is not available, which is serving as a gateway for the web server or any other client here, So this R4 is going to assume the master role or the active role and say, okay, now, hey, if active router is down, now you can pass through me, and therefore you will not have no downtime. So to do that, we also have to create what we call a virtual IP. A virtual IP, and this virtual IP will be used as the gateway for the web server instead of using the physical router. So here we can give it a virtual IP of 10.20.20.20. And that is what we are going to now configure on the web server as the gateway instead of the IP address of R3. So to do that, we go to the web server. Let's stop this scripting now. And then we change the IP configuration. The gateway here, instead of .3, we said it's going to be .20, which is the virtual IP address. So the next thing is we go to the active router or R3, which is going to be serving as our active router, and then we make sure that we configure it to be the active router. So to do that, we go to the interface G0/1, which should be serving as our active router interface connecting towards the server LAN, and we said standby IP address 10.20.20.20. So remember, this is going to be the virtual IP address that will be used as the gateway for the web server. So the next thing is we configure the priority, the standby priority, priority to be 101. So note that the default priority is 100. So that means any router in this HSRP group which has the highest priority is going to be acting as the active router. So that is why we give it a standby of 101, because the default is 100. And the next thing is we said standby preempt. So this command will tell router R3 that if you are down and then all of a sudden you come back on, so you found out that you are having the highest priority in the HSRP group, so preempt this active role and become the active immediately. So here you can see we have seen a message that says, okay, the standby state has come to active. So that means this router has now promoted itself to an active router in the HSRP group. Okay, so here you can see that the output of the source standby is showing us that the state is active. So that means this router is now serving as the active HSRP router at the moment, and the group name is HSRP-G gigabit 0/1-0 group name, which is the default one there, and that name is also good for us. And the priority is 101. So remember, we said the default priority is 100. So that means this router has the highest priority and it assumes the active role. Okay, so the next thing is we go to R4 and also do the Srp configurations to make sure that it also serves as a standby router. So to do that, we jump right into that router and we go to global configuration mode, and we can verify the interface that is connected towards the server LAN. So IP interface brief, and we see that the interface there is G0/2. That's where we have 10.20.20.4. So we say interface G0/2, and we configure standby IP address, standby IP 10.20.20.20. Okay, so this also automatically tells this router now you have been configured to be part of a HSRP standby group, and now that router also will be assuming the standby role since it will be configured with a default priority of 100. So standby. So here you can see already the message that was popping up, and it said this one is speaking HSRP, and then it's now on standby mode. So the state here is standby simply because the default priority is 100, and that router will assume the master role or the active role if the primary is not available. So that's it for the configuration. Now we go back to the web server and try to test how the router is actually reaching the DNS server, and if that primary route is not available, we should see an automatic switch over to the secondary route, which is going to be the active at the moment should be via R3 to the Google DNS, which is 10.20.20.3. If this primary role or primary link is not available, we should see the HSRP functions will now automatically switch the traffic from the web server going via R4 and to the internet cloud. Okay, so let's go to the web server and try to do our ping. So first of all, we trace so a.a.8, and we see that the traffic is going via 10.20.20.3, which is the IP address of R3, because that router is now acting as the active router. Okay, so we can do a continuous ping from the web server to the internet or to the Google DNS server, a.a.8. And now let's go back to the router and then shut down this link and see what will happen. So because traffic is flowing well and because the link is available, so if you go to that router and then shut down the interface that is connecting on the server LAN, which is G0/1, so interface G0/1, shut down. So as soon as we shut that down, so that means this router is no more available, or the active router is no more available. So you should be expecting that traffic should be switching from the web server, to the internet using another link. So you can see the traffic is back up after just few. Okay, so if you go back to this router in router R4, you can see that it has not promoted itself to active role. So if you issue the command, so standby, we can see that this router has now promoted itself to an active router. So traffic from the web server will just be down for a few seconds. That's where we see we lost that 2 packets there, and it is now back up and everything is flowing well. So here you can see that we only lost 2 packets. So if you do a trace again, initially we are going through 10.20.20.3 here, but now you see we are going now 10.20.20.4, which is the IP address of R4 and to the DNS server. Okay, so you can see how wonderful this backup technology is to make sure that some of your critical servers that needs to be accessed by people from the outside, is always on. So you have to ensure that there is 99.9% availability of these services to make sure that there is no downtime as far as physical link connection is concerned or logical backup is concerned. So you can see this router is now administratively down. So if you go back and bring this link up, so the router will come up, and after just a few seconds, it is actually going to reassume the active role because of that preemption command. Okay, so let's give it just, let's say, a few seconds for the network to converge. Okay, good. So you can see that trace now is showing us that we are still now going back again through 10.20.20.3, and the router was down. We are going through 10.20.20.20.4. So if you go back to the router, you should see that it has preempted and forced itself to become the active role because it has the highest priority. So standby, and you can see it is back to active mode. So this is so wonderful, and I enjoyed this video. So if you also enjoy it, please subscribe and click the bell icon to receive notifications whenever our new release are available, and I will see you in the next time.